Hello guys, now let's continue our course with our next topic, that is Floyd Warshall algorithm. So at the very first we will see what is Floyd Warshall algorithm, and then we will see the purpose of using this Floyd Warshall algorithm. So a weighted or directed graph is a collection vertices connected by weighted edges where the weight is some real number. Here you know the concept of weighted graphs. What are weighted graphs? Here the age values are present, means the values of ages are some real numbers, right? So one of the most common example of a graph in the real world is a road map. So what is road map actually? Road map is being used in Google Maps. For example, you want to travel from Maharashtra to Karnataka. Okay. So for traveling from Maharashtra to Karnataka, you are finding a path between them. At the moment you realize that you want to find a path which is shortest path to travel from Maharashtra to Karnataka. So at that time the Floyd Warshall algorithm comes. What you will do, if there is no direct path available from Maharashtra to Karnataka, you will find one intermediate place so that you could travel first Maharashtra to that place and then from that place to Karnataka. So likewise, in the same manner, the Floyd-Warshall algorithm works. Now, let's take this example. Tampa, Orlando, and Jacksonville are having some edges which are connected between them. So, from Tampa to Orlando, we will plot this 2D array over here and we will see which edge is not present over there. So, from Tampa to Tampa, is there any self loop? No, so it will be 0. Now from Tampa to Orlando, what it is? It is 1.7. Tampa to Jacksonville. So Tampa to Jacksonville, right? It is 3.4. And likewise, in the same manner, if you go from one vertex to next one, and you will find the edges between them. But only the thing which is going to change over here is that to travel from Orlando to Jacksonville, there is no path available, right? You could see here. So where there is no path available over there, what you will do, you will put simply infinity. And wherever, like Tampa to Tampa and Orlando to Orlando, there is no self loop present. So there you will put the 0 value. And wherever the edges are present, so there you will put the weights of them. Now first we will see how to store a weighted and directed graph. So for that we use the adjacency matrix again. So what do we do in adjacency matrix? We store the vertices in 1D array and we store the edges, or we represent the edges in 2D array, right? So two arrays are required over there. So let's consider this directed graph and represent the edges between them. So in this, it is a directed graph. So obviously it is having direction of each edges. So let's take this example and let's represent this edges. So from 0 to 0. First we will see from 0 index position to 0, means from 0 to 0. Is there any kind of self loop? No. So what we will input here? We will input 0 over here. Now from 0 to 1, it is 6. So we inputted 6. From 0 to 2, what is from 0 to 2? It is 5. So we inputted 5. Now observe here, from 0 to 3, is there any kind of edge present over between 0 to 3? No. So what you will input there? You will input the infinity. And likewise, in the same manner, you have to construct this whole 2D array. So in the same format, when you construct the 2D array, you will came to know that how much edges are not present over here and how much edges are present. So both the data will be saved in this 2D array, right? Now what you will do after this, you will apply the Floyd-Warshall algorithm, and what you will do, you will update this matrix D with the shortest path through immediate vertices. Okay, so after sorting a weighted or directed graph, the next step is you have to find the shortest path between the edges, and you have to update this value, this 6, 5. Even you will update this infinity also. Suppose you found some path between 0 to 3, some path to travel from 0 to 3. So what you will do, you will update this infinity and you will put the weighted value over here. Okay. So we will see it further. So a Floyd-Warshall algorithm. In that, given a weighted graph, we want to know the shortest path from one vertex in the graph to another. Right now, just I have said this, I have committed this to you, that you have to find the shortest path from one vertex in the graph to another, and then you have to update it. So the Floyd-Warshall algorithm determines the shortest path between all the pairs of vertices. And remember, if there is a shortest path updated between all the pairs of vertices, it could be called as the complete graph, right? So what is the key difference between Floyd-Warshall and Dijkstra? This you could study in algorithm analysis in that chapters. So this is the further part of the data structures. You will see this later. Now, if V is the number of vertices, then Dijkstra run in big O of V square. What is this? This is the time complexity. And what is actually Dijkstra's? Dijkstra's is the another method, or is the another algorithm which also finds the shortest path between the two nodes or two vertices. So I am taking in consideration the Floyd-Warshall algorithm because there is one difference between Floyd-Warshall algorithm and Dijkstra, and it is like using Floyd-Warshall algorithm is more efficient rather than using Dijkstra's. Okay, so we will see it in further. Like we could just call Dijkstra V times passing a different source vertex each time. Means what do it means? Bigger of V into V square equals to bigger of V cube. And this is the time complexity of Floyd-Warshall algorithm. So in Floyd-Warshall algorithm and Dijkstra, the major difference is that Dijkstra doesn't work with negative weighted edges. Like if from A to B there is a edge which is present, as we said that the condition is only that real numbers are required. We haven't specified if positive numbers are required or negative numbers are required. Both are valid. So if A to B, my weight is minus 200. So in that case, my Floyd-Warshall algorithm will work fluently. But in Dijkstra algorithm does not work with negative weightages. That's the only difference, and that's why I said that Floyd-Warshall algorithm is more efficient to work rather than using the Dijkstra's algorithm. As Dijkstra algorithm is having big of V cube as a worst case time complexity, and Dijkstra is having bigger of V square. So I know that the bigger of V cube, this time complexity is worse than worst according to Floyd-Warshall algorithm, but still it runs in fluent manner, and it also don't have any kind of abstractions to work with negative weight edges. So in Floyd-Warshall algorithm, first what is done, the vertices in a graph be numbered from 1 to n. Means there are n number of vertices. The actual meaning of this statement is there are n number of vertices. Imagine finding the shortest path from vertex I to vertex T, like this. This is the I and this is the J. So these are two vertices, and you want to find the shortest path to reach from I to J. In this situation, what you will do? You will consider the two situations. K is an intermediate vertex on the shortest path, and K is not an intermediate vertex on the shortest path. So what do actually it means? What is intermediate vertex? Intermediate vertex is the one which helps to find you the shortest path. For example, K. So this K vertex is the intermediate vertex because, for example, first you will go from I to K and then you will go from K to J. Likewise, you will reach towards the J from I. So here K is working as an intermediate vertex. Like it is working as like an agent to find the shortest path, right? Now let's consider this example of Floyd-Warshall algorithm. Consider this graph now. This is the directed graph where edges are present and some vertices are present. So what you will do, you will represent this edges using 2D array. So how you will represent? This is one, first vertex, second vertex, third vertex. First vertex, second vertex, and third vertex. Okay. Now let's see between 1 to 1. Is there any self loop? Means is there any path from travel from 1 to 1 only? No. So you will put 0 there. Now from 1 to 2. What is 1 to 2? It is 4. Now from 1 to 3. What is 1 to 3? It is 7. So likewise in the same manner you will update each and every value. But take a look over here. Now from 3 to 2. Is there any kind of edge present to travel from 3 to 2? No. So what you will put? Infinity. Right. So what are these? These are the original weights. Why original weights? Because after applying the Floyd-Warshall algorithm, we are going to update these values. Okay. So that's why it is called as original weights. Now, let's do the updatations and let's find the shortest path among them. So, at the first, consider the vertex 1. This is the vertex 1. Now, you could see here, first we will replace this infinity. Why we are going to replace this infinity? Because there is a path which isn't existing to travel from 3 to 2. So, let's find out. So, what are the ways to go from 3 to 2 is, first you will go from 3 to 1. That is, first you will travel from 3 to 1 and then you will reach towards 2 by using this one from 1 to 2. Right. So here 1 is acting as like an intermediate vertex. Right. With the help of 1, we are going to travel from 3 to 2. So this is called as intermediate vertex. Now, what is the weight of traveling from 3 to 2? So, it would be 6 plus 4. That is, from 3 to 1, it is 6 plus from 1 to 2. What is the weight of edge which is connecting 1 to 2? It is 4. So, 6 plus 4 would be 10. And now we will update this value into our matrix. And what you will put? You will put 10 instead of infinity there. Now, this 10 is being replaced, this infinity is being replaced by 10. Moving further, let's consider the vertex 2, means the second one, the vertex. What you will do? You will find the shortest path to travel from 1 to 3. Actually, it is given 7, but is there any shortest path to travel from 1 to 3 which is less than 7? Okay, so it can be called as the shortest path. So to travel from 1 to 3, the one way is to go through this direct edge which is having the weight 7, but the another way is going from 1 to 2 and then 2 to 3. Okay, going from 1 to 2 and then from 2 to 3. So what are the weights to go from 1 to 2? It is 4. And from 2 to 3, it is 2. So the answer is 6. Now let's update this value again into our matrix. Now what is the, so this 6 is updated. Now what is the another consideration of vertex 3? So there nothing changes, right? Because we have seen the travel 3 to 2, then we have seen the travelation of 1 to 3, but from 1 to 2, the only way to travel is the direct edge which is given, and it is 4, because no such shortest path exists to travel from 1 to 2 less than 4. So we will do nothing with the third vertex. Okay, so this is how the Floyd-Warshall algorithm works. It replaces or it updates the shortest path among the nodes. Now, looking at this example, we can come up with the following algorithm, that for k equals to 1, I equals to 1, j equals to 1 to n. T of ij means traveling from one node to another node, like we have traveled from 1 to 3. Okay. Minimum means shortest path. What would be the shortest path? The shortest path would be the addition of I to k plus k to j. Means adding up the paths, like from 1 to 2 and 2 to 3. This 1 represents I, 3 represents j, and 2 represents k. Means doing the addition of weights of first traveling from I to k and then k to j. So that would be the shortest part of the what? Of the edges which we are going to travel from I to j. So this is how the shortest path is found. So the final D matrix will store all the shortest path. Like we have updated each and every vertex, we have seen for the shortest path, search for the shortest path, and then we have updated it. So that would be our final D matrix. So hey guys, thank you so much. I'll see you in the next class.